Hello everyone and welcome to today's session. Very few people have joined till now, so let's wait for 5 more minutes so that people who might be running late can join and then we'll start. It's 5 minutes now, so I think we should start with our session. I hope I'm audible. If someone can indicate if everyone can hear me. Just type in the chat box and let me know if you all can hear me. Okay, great. And I hope you can see my screen as well. Okay, let's start. Okay, welcome to today's session. So today we'll be solving assignment 3 from week 3. So it will be assignment 3 from the previous runs, not the current assignment which you are assigned, but the assignment from previous runs. So these are the lectures which you would have covered in week 3. First would be the relevance of sustainable design in contemporary context, how in present scenario, sustainable design is relevant to us all. Then built environment and energy consumption. So how the built environment is involved in energy consumption, how it uses energy for in what context, for what purposes, and how more efficient and sustainable energy consumption can be done, like using techniques like insulation, air tightness, ventilation, and things. Then you would have studied reliance and dependence of building design on energy, how when you focus on energy or energy efficiency as a concern while designing buildings, how the design of the building depends on that concern. So you would have studied things like storing energy in the building itself, how that can be achieved, and then how an integrated design process can be achieved where you keep energy efficiency at the center of the design concern. Then you would have studied the current scenario of sustainable design in the Indian context and then the international context as well. So, for Indian context, you would have studied several concerns related to sustainable design, like urban heat island effect, how to combat that, then how social interaction in built environment can be achieved, and how that is a part of sustainable design, and then how pedestrian oriented designs can be achieved, or how space arrangements in different designs are taken into consideration. And then, in terms of the international scenario, you would have studied things like how nature-based biopolymer composites are used for building design, and how they help you achieve sustainable design or a sustainable material in building design. Then, how can you design from scrap using materials from the scrap, so recycled goods or other materials which are end of their life cycle in their earlier context, but then that scrap can be used to construct buildings. Then you would have studied several examples of site integrated design, so how buildings can be designed in integration to the context of their site and their surroundings, their climate and everything, so that they follow a sustainable design pathway. And then designing in sync with nature, so how the natural surroundings around a building or the natural components of site or context of a building can be integrated into the design itself. So I hope this is clear. So these were the lectures which were covered in week 3, and we will be solving assignments based on these. So again, I'll be going over the questions in the assignments, and then I'll tell you the background material related to it. I'll tell you how to approach the questions, what to focus on, what to pay attention to while solving the question, which materials to use while solving the question, because again this week most of the questions are theory questions, and then how to approach the question, how to solve it, and I'll also be giving you some further material for reading, or the sources of the background material which I have composed the answers with. So you can further go into detail and study more about the particular subjects or associated material if you want to do that. So let's start with the first question. So first question today is, which sector in the USA accounts for half of the energy consumption as per the Alliance to Save Energy? And you're given four options: industrial sector, building sector, residential sector, and none of the above. So this actually comes from calculation from the Energy Information Administration Department, from the that is a department of the USA government, which takes care of the energy information or the energy consumption and use information all over the USA. So in their assessments, they found out that building sector accounts for almost half of the energy consumption in the US, and this is a graph that they produced, which counts in million metric tons of carbons that is produced by different uh, uh, by energy that is used in uh, building, transport, and industry. So as you can see from the graph itself, that the buildings is the most energy and which creates the most carbon out of all the three different uses which are studied here. So according to this, you can very easily see what the answer to this question will be. I've also provided the source of this information and the EIA government website. So you can visit the source, and you can even see further information on this. So like if you go to this, you can see the source and uses for different energy consumption. So you can see for petroleum and other liquids, natural gas, electricity, and everything. So how much electricity is being consumed from different sources by which sectors and how much. So there are several sort of uh, reports on different type of energy uses by different sectors, by different populations in the country and everything. So you can even go and visit these different evaluations and reports if you want to study further, and you can get an idea of how these calculations are made, what key components there are to be studied while you study energy usage and or the carbon dioxide generated by different kinds of energy usage. So like this is an example of a study which shows that more than half of the US electricity generating capacity will by 2023 will be by solar. Uh, then it for example, this shows that coal and natural gas plants will uh, account for 98% of the capacity requirements by 2023. So think like this, and then there are even maps showing where these plants are located and everything. So if you want further information on sources and uses of different type of energy in the US, you can go visit this website. Coming back, so I think this question is very clear. Which option to choose? As you can see from the graph itself, that the building sector accounts for more than half of the energy consumption. Okay, moving on to the next question. Okay, another part which I wanted to elaborate a little bit about this question is that when we are talking of the resource use share or the energy use share, that in this graph, or in this case, we were talking about the energy share used by different things like different sectors like building construction sector, transportation sector, or the industrial sector. There are even calculations or studies calculating the resource use by different aspect or different type of use in the building sector itself. So there can be energy used by the building sector, or the energy used in production and usage of raw materials which is there in the building, then water usage in the building, and then land. So land use changes, land use change conversion, which is associated with the building construction, and then pollution emission calculations for like CO2 emissions, then solid waste generation, then water effluents generated by the construction process. These also can be calculated. So this is the example which you would have seen during your lecture. Another example which you can go through if you would like to study the resource use share of the buildings, or resource use share of the building, or things like what energy different kinds of resources use. You can go through this study. So in this study you see the resource use or energy use by different processes or different elements of building construction, or even throughout the building life cycle, is calculated and studied. So there are things like energy used in heating, then for heating water, then for electricity in the building, then energy used in all of the building materials that are used in the building, then different material related processes which occurred during the building construction or the operation phase, and then for the site construction. So I'll just show you. So this is the just give me a moment. This is the study. So as the study also points out that building construction can influence up to 42% of the final energy consumption and 35% of the greenhouse gas emission that are associated with building or construction sector, and even for 50% of all the extracted materials. And it can help you if we optimize this building construction to fit sustainable practices. It can even help us to save up to 30% of water consumption. So what this study does is that it outlines different aspects of material efficiency in buildings, and it does an assessment based on different building materials used in the building and their efficiency. So it takes care of all the different building materials which have been used, and how efficiency of each material affects the overall energy usage or material usage in the building. So going down, you can see it takes into account different aspects such as scarcity and availability of the abiotic building materials. So the abiotic building materials that have been used. So then the greenhouse gases that is generated in usage of different kinds of building material in the building process. Then it also takes into consideration the land use changes, so irreversible damages which are caused by land use changes which occur during the building process or building operation, that it also takes into account. Then takes into account the cost and productivity, so how efficiently different materials can be used. Then existing standards and regulations associated with building construction and such things. So the metric which it uses is the abiotic depletion potential of buildings, and this is the calculation method which they have outlined. So they use the life cycle assessment method and associated with the building, and base their calculations off of that. So for example, this table you can see, so they show the ADP factor of different building materials, so aluminum, concrete, fossil material, gravel, and other, and total mass of the material that is used, and what is their uh, input into the building, and then uh, things like uh, fossil energy inputs that is used to use those materials into construction techniques. So total mass of the material, and then how much fossil energy is used, uh, and using all of this, they create this fossil energy consumption over life cycle of the building, how much fossil energy consumption is done for different kinds of functions which are there in a building. So I think this is a very informative study which you can go through if you want to study a little bit more about different resource use share within the building itself. Okay, moving on to the next question, which is which of the following is not supportive and in designing and building an energy efficient building? So again, focus here on how the question is phrased. So it says not supportive, it does not say supportive. So select your options very carefully, focusing that it is asking which of the options stated are not supportive. So the options you are given are bioclimatic architecture, high performing building envelope, and high performance controlled ventilation. So I'll tell you a little bit about what all of these things are. So first, bioclimatic architecture. So bioclimatic architecture, it deals with sustainable design and material consumption, and for energy, also energy efficiency in building design and construction. It involves several aspects such as building shape and orientation, protection from solar heat and radiation, and integrating the building design with both active and passive solar uh, systems, solar design techniques, etc. So many a times people confuse bioclimatic architecture with vernacular architecture. Although there are several similarities between the both types of architectural styles or architectural design styles, as both of them focus on adaptation of the building to the climate specifics of a particular area. Still, both techniques are different based on the type of technology they use and where the technology is derived from. So you see vernacular architecture or vernacular building design techniques, they come with knowledge that is developed as a part of a particular area, so as a part of their tradition or their heritage, and it is transferred from one generation to another. It is part of a gradual learning. However, bioclimatic architecture is not grounded in one region only. It can be used globally if it is suitable for the particular climate. So it's not like a particular type of ventilation technique is if it is suited in different climates, it can't be used in a different area. So a particular type of bioclimatic architectural element can belong to any place. It's not uh, tied to one region like vernacular architecture techniques are. And apart from that, it what it does, it is that it uses more contemporary technological solutions in building design, which is different from vernacular architecture, because vernacular architecture uses design solutions which come from traditional architectural techniques, not the contemporary ones. So I have provided two sources for you if you want to read further on this. So this is article written about the bioclimatic architecture. So it goes into detail on what bioclimatic architecture is. So what is its concept? So things like how user comfort is detailed in bioclimatic architecture, and then how bioclimatic architecture borrows some lessons from the vernacular architecture like passive cooling and heating. So that is discussed in detail. So things like chimney ventilation and cross ventilation wind towers and things are integrated. So these things are borrowed from vernacular architectural practices and integrated into the bioclimatic architecture. Then it also discusses example of the Tsinghua University in Beijing, how the architecture and design of the university has used bioclimatic architecture. So you can go into detail on what techniques are integrated into the building design. So things like they use photovoltaic elements, then silk screen glass panels, radiant ceiling, then how it is integrated with the site, things like that, how it's oriented to get the most of the solar radiation in the months that it is needed. So you can see that, and it is very visible from even the visuals of the building itself. You would not call this building a building of vernacular architecture because it does not follow practices from vernacular architecture, but it follows several of the techniques which are borrowed, integrated with modern or contemporary technological solutions to create a building which is in sync with the climatic condition of the particular area. So another example or case study which this study discusses is of the building Solaris in Singapore. So you can go through that as well. And then it discusses the key differences between the vernacular and bioclimatic architecture. So that also you can have a look at in detail if you would like that. Apart from that, this is another uh, resource which I have shared for further reading if you want. So what bioclimatic architecture is and what are the contemporary or current research going on in that area. So there are several new research coming up in that area. So for example, what are the new concepts and applications of solar photovoltaic system for creating net zero or low zero energy buildings? So that is also part of bioclimatic architecture. And then how do you integrate energy savings into building and building complexes? That again is a part of bioclimatic architecture. So, and then it even discusses specific passive solar system in specific techniques like use of passive solar system in architecture, and then things like how the specific window shading levels and indoor ventilation systems can be selected for optimum ventilation in commercial buildings. So things like that you can go further and study if you want to study more about bioclimatic architecture. Another thing which I would like to go on, I would like to discuss a little bit is about the various principles of bioclimatic design. So there are things like how it, although there are several things associated with bioclimatic design, the key principles can be first is the shape of the building. You keep in mind the shape of the building while designing. So, do you want it to be compact to reduce the surface that are in contact with the exterior, or in the case of warm and humid area, when you would want to increase ventilation throughout the building more, would you design it in that way? So shape of the building is one key thing which you keep in mind while designing. Then the openings associated with the building, so orient them at a proper orientation according to the site orientation and wind flow orientation as well, and also according to the spaces within the building, and then in how the interior spaces are laid out according to heating requirements. So that also will vary according to the climate of the area. And then how you manage the external envelope. So if you this is for regulating the amount of solar heat transfer in the building. So you can use things like shading devices, or even envelope treatment like reflective colors and surfaces. So shading devices, in case of if you want more shading to reduce solar heat gained by the building, or you want to or you want to uh, create or you want to regulate solar heat gain in the building. So that is there. So these are some of the principles associated with bioclimatic architecture. Coming back to the question, so which of the following is not supportive in designing and building energy efficiency in the building? Okay, so we still have high performing building envelope and ventilation. Coming to the building envelope, so building envelope, as I discussed in earlier sessions as well, it is basically the physical barrier between the exterior and interior environments, which encloses any structure. So it comprises of the roof of the building, the walls, the openings like the windows, doors, etc., the foundation of the building. So what it does, it protects the interior space within the building from the external environment, like temperature, wind, humidity, precipitation like snowfall, rain, etc., and ultraviolet radiation. So the and also it is used to regulate the internal temperature and light, temperature, and other uh, factors which contribute to the indoor comfort. So several other things apart from the building envelope uh, are included in this, like the HVAC, but here we are talking about the high performing building envelope. So what a high performing envelope does is that it reduces heat transfer in both directions, which decreases the cooling load or heating load in the building. So cooling load will be applicable in the case of summer months, or in the case of an area which has a climate which is hot, or heating load will be applicable for the winter months, or in the case of an area which has a cold climate. So what we do to the building envelope is that we make sure that it maintains a certain insulation, so that the heat exchange, or the exchange of humidity, or other things is regulated in order to ensure comfortable situation within the interior of the building. So I have linked two sources which you can refer to if you want to do further reading. So, energy and environmental assessment performance of building envelope in the cold climate. So, this is a particular case study for a building envelope in the cold climate. Here, this is actually a study of a particular building material or a particular stud wall system which they have taken as the baseline and see how it performs uh, by uh, by assessing the uh, performance of the building envelope in a cold climate. Another source which I have shared is a book which you can go through. So this book that is called Sustainable Facades, it gives you an account of how different facades can be used as high performance building envelopes. So first it discusses different climate classification system, and then the characteristics of different facades that can be used for different climate systems. It discusses things even like building orientation, different facade types, material properties, etc. And then what are the methods which can be used for improving thermal comfort within the building. Another key thing which it does is it presents in-depth case studies which illustrates how different design strategies or building elements or design elements can be used or are used in the building for different climates. So if you want, you can go through this as well to read further on this subject. Then coming to high performance controlled ventilation. So one key aspect that comes while studying ventilation is that due to the stack effect, a lot in the heating season, the heating season, or you can say the cold season when heating is required, uh, the cold air from the external environment comes into the interior space, and the hot air which is present in the interior environment escapes from the building from uh, openings that are situated higher up in the building. Similarly, in the cooling season or in the hot weather, the cold air escapes from the openings which are located in the lower parts of the building, and hot air is enters the building through upper openings of the building. So this is the stack effect which works against the heating and cooling which is done inside the building, and we need high performance controlled ventilation systems to tackle this stack effect taking place in different climates and different weathers. So what we want from a high performance controlled ventilation system is to have provision of good indoor air quality without any electricity demand for moving the air, and to improve the thermal comfort within the building in the interior by controlling air speed and ventilation rates. Uh, this is done often through some sort of mechanical insulation and heat recovery method. So I have attached two more sources for further reading. So this is a study for controlled natural ventilation for energy efficient buildings. So it gives you account of how natural ventilation in the building can help save on cooling and electrical energy consumed in cooling the building. So you can go into this study and see the different control strategies that are used, and they discuss. And you can even see the modeling approach they have used for their study, if you would like to do such kind of modeling for yourself. Apart from that, you can even see this study. So this is a example of this is example of a study which uses hybrid ventilation control strategies for zero cooling energy building system. So you can go see this study as well, how they've used different systems in their building to create a ventilation system which uses almost no energy for ventilation in this building. Okay, coming back. So coming back to the question, now you know that all these three, bioclimatic architecture, high performing building envelope, and high performance control ventilation, all of these support in designing and building an energy efficient building system. So I hope it is clear to you what the answer of this question is. Coming to the third question, which is passive solar system fall under which of the following categories? So you are given four options. First, bioclimatic architecture, Greek architecture, temple architecture, and Buddhist architecture. So as we discussed earlier also in context of bioclimatic architecture, that passive solar system is a key component of bioclimatic architecture. So I think this question or the answer to this question should be clear from that aspect itself. But apart from that also, I'll explain a little bit to you about what solar energy systems are and how they are used actively and passively in building design and construction. So, what solar energy system does is that it uses the sun's rays or energy from the sun for either thermal energy, either in the form of thermal energy, or or some using some mechanism that thermal energy is converted into electricity, and then that is used for different function of the building. So there are two key ways of harnessing the solar energy for building systems. First is the passive system. So this is things like uh, things associated to the structure or design of the building, such as placement of the buildings, what materials you can use to optimize heat gain. So either if you want heat, which materials to use, if you want to insulate the building, if you don't want heat gain within the building, which materials to use. So it optimizes the use of heat or light directly from the sun, so both heat and light. And then active systems. So what active systems do is that they convert the sun's energy into a more usable form for the building, such as for uh, uh, creating for generating electricity for electrical purposes within the building, or for heating water for hot water uses in the building. So solar energy system can be used for different things, such as space heating for the building, heating water, or for photovoltaic energy generation, lighting within the building, etc. If you want to further read about active and passive solar energy systems and how they are used in the buildings, you can go to this link. So you can see here, it talks about the passive system, how passive solar space heating can be used for building. So things like creating sun spaces, classrooms, etc. can uh, act as strategies for passive solar space heating, and then it talks in detail about active systems. So how active solar space heating is done, then how solar water heaters are used in buildings, and how much energy they save, how much cost effective they are, things like that. And then how photovoltaic cells are used as a for energy generation as a active solar system technique for building energy usage. And then concentrated solar power, how this system is used for generating electricity or build for usage in the building. Apart from that, I also want to discuss the elements of passive solar design. So there are several things related to passive solar design. This is an article which discusses 5 key elements, but apart from this also there are several other elements which you can read further in detail. So these 5 key elements, first is the aperture or collector. So it is sort of an opening on an area or a surface area within the building or on the building surface through which sunlight enters the building. So sunlight either for heating or for light, it can be for either purposes. So here in this case, this is the aperture from which the sunlight is entering. So you can see the aperture is designed in a way that it blocks out the summer sun and it lets in the winter sun in the building. Then there is the absorber. So absorber is a hard surface which is used as a storage element in the building. So storage for heat. It could be a masonry wall, it could be floor or a water container that can store energy from the sun and can transfer it to the building. Then thermal mass. So it is the material that retain or store the heat which is produced by the sun while the absorber it is exposed to the surface. So the thermal mass and the absorber are often connected to each other so that energy transfer from the sun can to the thermal mass can happen. Uh, then distribution. So this is the method by which solar heat circulates from the point where it's absorbed through the absorber, collected or stored in the thermal mass, and then it is circulated within the usable space of the building. So you can see the heat from this thermal mass is radiated within the building. So it can happen either by conduction, convection, or radiation, the 3 phase. In many examples, even fans and ducts and blowers are used to distribute this heat gain from the sun within the building or within the usable space of the building. And then there are controls. So controls are the things like roof overhangs or other shading devices which can be used to control how much heat or how much light you want within the building or you want from the aperture. For example, this overhang here is used as a control so that it blocks out the summer sun but lets in the winter sun. You can further visit this link if you want to see or read a little bit more about passive solar design or passive solar design techniques. So this article goes into detail about several things like passive solar heating, so things like direct gain and indirect gain, then how shading devices can be used for cooling, uh, for ventilation, for convective cooling, and things like that. I hope this is clear to you, and you now understand what passive solar design techniques are. Okay, going to the next question. So, what percentage of energy is used in water heating in warm climate countries? And you are given several options. So, this actually comes from a study done by WRI. which studies how building efficiency can be accelerated. So what they in a part of the study was what is the share of different energy uses within the building. So you can see energy use in cold climate and energy use in moderate and warm climate countries differs a lot. So for example, in the cold climate, space heating space heating uses the most percentage of all the energy consumption in the building, while in warm climates, cooking is the component which uses the most energy, closely followed by water heating. So you can go to this link and further see for yourself what different the different aspects of building energy efficiency this study talks about. So there are things like what are the different opportunities for sustainability or sustainable development within the building construction or building design arena, uh, and then what policy paths to follow, what is the role of local governments and governance bodies in shaping livable cities, what is the role of buildings in achieving sustainable urbanization, things like that. So you can go to this study and see for yourself how what role buildings play in creating sustainable urban energy systems and such. So coming back, uh, what this question actually asks from us is that what percentage of energy is used in water heating. So now focusing especially on water heating, so you can see water heating and in case of warm climate countries, so warm climate and water heating, it's 30%. So I think you know what the answer to this question is. Okay, moving on to the next question. So, zero energy buildings improve interior air quality. Zero energy building improve interior air quality falls under which type of goal for the roadmap of non-industrial countries? Okay, so this question actually talks about the non-zero energy. Uh, Net Zero Energy Building Alliance and the roadmap for the alliance that is followed by the non-industrial countries. So what a roadmap is? So roadmap is essentially a pathway or a detailed set of goals and procedures which is decided by okay, which is decided upon by the country. Uh, uh, okay, I don't know if there is some problem. Okay, so coming back, so what the roadmap is, it outlines different goals. So according to different time periods, so what goal should be achieved in the short term, what goal should be achieved in the middle term, and what goal should be achieved in the long term, so that uh, uh, the alliance for achieving net zero energy buildings is that goal is followed. So okay, there is a question by Arvind asking which assignment this I find these question in any of the week assignment in your course portal. Okay, so Arvind, these are the questions which were assigned in the previous run. So these are not the questions which are assigned in the current run. I am supposed to solve the questions which were assigned in the previous runs of this course. Just to let you know how the questions are to be approached and how they are solved. I'm not supposed to answer the questions which are assigned to you currently in this term because those questions you are supposed to solve on your own. So these are the questions which were assigned in previous runs, and I am solving those questions for you. Okay, coming back uh, to our question, which is the net zero energy building alliance and the roadmap by non-industrial countries. So this image here shows you the roadmap for the non-industrial countries. So you can see there are short-term goals like creating a community vision, which involves the industries, the government, the professionals associated with it, and even the local community, and how the health institution formulating a common vision involving everyone for following the net zero energy building alliance, then following best practices and how they can influence building design decisions uh, in the case of non-industrial countries. Then things like improving interior air quality, developing a local comfort model, promoting energy efficiency and renewable energy technologies, low-tech industrial infrastructure, etc. These are examples of short-term goals. Then there are medium-term goals like introducing the high-tech solutions, maximizing the performance of low-tech industrial infrastructure, uh, achieving the minimum objective for connected loads, standardizing low-tech net zero energy building, uh, then including a minimum target for renewable technologies, things like that come under the medium term goals. Then things like introducing smart plus low carbon grids, using plus energy building, so creating a positive balance of energy and CO2 emissions. So not only creating net zero buildings, but the building should be able to produce even surplus energy apart from the load that it is consuming, and creating negative CO2 emissions. So in some way, shape or form, sequestering carbon which is present in the environment. So these kind of goals are long-term goals which countries can follow. So this is uh, from this image also you can see what kind of goals fall under which categories, and specifically the question asks about the interior air quality. So you can see here improving the interior air quality falls under the short term goals. So I think it is clear to you now what the answer of this question is. Going to the next question, which is what is energy performance index? And you are given four options. Is it partial energy upon total energy consumed by building over a year, or total energy in the building over a year divided by total built up area, or total energy in a building over a year divided by total site area, or total energy upon partial energy multiplied by built up over a year. So what energy performance index is, it's actually a metric which is used for benchmarking energy uses in commercial buildings. So it is calculated, uh, the energy in the EPI is used calculated by seeing the energy used per unit area measured as kilowatt hour per meter square per year, or it can be also calculated as kilowatt hour per person per year. So it can be calculated in terms of both, in terms of the built up area or in terms of the people which occupy the building or the area. So as the answers given to you in this question are pertaining to the built up area, so we'll take built-up area into account while solving this question. So as you can see, the unit for this is kilowatt hour per meter square per year. So kilowatt hour represents the total energy that is consumed by the building. Meter square is for the total built up area of that building, and year is to specify the time period. So the energy used per year. So kilowatt hour per year is the total energy consumed by the building in an year, divided by the total built up area of the building. So I think it makes very clear what the answer to this question is. And another key thing which I want to point out here is most commercial buildings in India have an EPI between 200 to 400. While for any building to be called energy conscious, it should have achieved an EPI which lies between 100 and 150 kilowatt hour per meter square per year. Although the national benchmark is actually 180, and any building which achieves an EPI of 180 is considered ECPC compliant. So I hope this is clear to you what EPI is and how it is measured. Another thing which you might have seen discussed in the lecture is that how EPI can be reduced. So as you can see here, I mentioned that most commercial buildings in India still have an EPI which lies somewhere between 200 and 400. While for the building to be considered energy conscious, the EPI needs to be decreased and brought down between 100 to 150. So how this can be done is that it can be done through including passive measures, and then energy efficiency using energy efficient building techniques in cooling and lighting of the building. If you want to read about this more, you can follow this link and go to this website, which discusses a little bit more about building design and how EPI can be considered in building design. And there are even further related sources which are linked here, so you can further go and see. Okay, coming back. Okay, so I hope this question is clear to everyone what energy performance index is. So the next question, it talks about climatic zones of India, and it asks that Bangalore falls under which climatic zone of India, and you are given four options: hot and dry, warm and humid, composite and temperate. So there are five key climatic zones which lies in India: hot and dry, warm and humid, temperate, cold, including both sunny and cloudy, and then composite. If you want to see which parts of India lie under which climatic zone, you follow this link. This link will take you to the energy conservation building code, and you search for appendix E within this code. So this is the appendix E. Appendix E gives you the climate zone map of India. So you can see from this map which parts of India lie within which climate zone. So you can see Bangalore lies somewhere here. So you can, if you superimpose the map of India or the location of different cities with this map, you can find out which climate zone the particular city lies in. Apart from that, you are also given this table which tells you a little bit more about different climatic zones. For example, hot and dry. This climatic zone is characterized by having high temperature, low humidity, and low rainfall, intense solar radiation, generally a clear sky. It has hot winds during the day and cool winds during the night. The terrain is usually sandy or rocky, with very little vegetation, and it has low underground water table, with very few sources of surface water. Similarly, it details out the characteristics of different type of climate conditions. So for warm and humid, temperate, cold and sunny, and composite. It also details out other things like what is the summer midday high and low temperature, what will be the winter midday low and winter midday high and winter night low temperature, what is the diurnal variation in temperatures, and then what is the mean relative humidity in each climate, what the annual precipitation looks like in each climatic condition, what the sky conditions will look like, and also example of places within India where this kind of climate can be observed. Also, you are given the climatic zone of major Indian cities according to this climate classification. So if you come back, we have been asked about Bangalore, which climatic zone it falls under. So you can see from this, Bangalore falls under the temperate zone. So I hope it is clear to you how to solve this question. So to solve this question, you have to follow the ECBC climate zones of India. You can just go to the appendix E and check from there which particular climate zone a particular city falls in. I hope this question is clear to everyone. Okay. Moving on to the next question. What is the mean volatile humidity of Kerala? So, I have one issue with this question. I did not find anything related to mean volatile humidity. I think there is an error, and what this question but actually is asking is about the mean relative humidity. So what relative humidity is, it is the amount of water vapor present in air, expressed as a percentage of amount needed for saturation at the same temperature. So what it represents is the moisture content or water vapor content of the atmosphere, expressed as percentage of amount of moisture that can be retained by that atmosphere at maximum moisture holding capacity at any particular given temperature and pressure, without any condensation happening. And what this question asks about is the mean relative humidity. So what mean is or the arithmetic mean is of any data set is the sum of all the values divided by the total number of values that are recorded in that data set. So it essentially represents an average and gives you an idea of what the average uh, of that data set can be like. So in this case we are talking about mean relative humidity. So that will be calculated based on calculating the relative humidity over of several instances. So for if you are calculating the mean relative humidity with for a day, so relative humidity would be measured over several instances during the day at uh, different intervals, and then a mean of that data will be calculated to give you the mean relative humidity within the day, or it can be even calculated for a particular month or the same month over several years, how the relative humidity has changed over a particular time, so things like that. So this is what is meant by mean relative humidity. So what this question asks is what is the mean relative humidity for Kerala? So for this again, let's go back to the ECBC guide. Uh, let's come back to this table. Okay, so let's see here. You can see Kerala is lies in the warm and humid climate classification, and as I told you that you can even see the mean relative humidity of the particular area using this climate classification table. So you can see from this table the mean relative humidity in the case of Kerala is 70 to 90%. I think this also is clear to you what the answer to this question is, and how you can see the relative humidity or mean relative humidity for different cities or different states of India. So if you want to check the mean relative humidity for any state or any city in India, you can just go to this uh, user guide, ECBC user guide. So either you can see the climate the climate of the particular city uh, in this table, what climate it is, and then you can check from this table in case of which climate what relative humidity it will be, or if it's not a major city and it's not given in the table, you can superimpose the city on this map, or you can identify where the city lies within this climatic zone map, and using this you can identify the climate zone of the city, and then go back to this table and identify what relative humidity that city or that particular state will have. Okay, coming back, I think this question is quite clear. So moving on to the next question. So next question asks, school in the sky is a school building designed by architects on a hilly terrain, inculcating the terrain features which are present uh, in which country? So this talks about a specific case study of school in the sky. So this is actually located in Nepal, and I have provided a link to uh, some details about this particular case study. So this is the school which this study is talking about. It's located in Nepal, and what this study has done is that, or what this design has done is that it has used the natural terrain of the area and used it to make a very dynamic and interactive space for the students uh, without which is in harmony with the site itself. So this is what this study is talking about. So I think this question is clear. If you want to go into further details about uh, this design and what it talks about, you can visit this link and see for yourself. Uh, Coming to the last question, which is Suzlon 1 art building is located in which city? Okay, so uh, this is yet another building uh, which is located in Pune, uh, India, and what this building is. This building has been designed in collaboration with the Suzlon Energy Limited. So that is a world leading wind energy company which is based in Pune, India. So what they have done is that they have created a building which they themselves term as the greenest building in India. So if you want to go into further details on what techniques they have used in their building design, so that they can call it a green building, or for creating a green building, you can go visit this link and see for yourself. So for example, uh, they have exclusively relied on non-toxic and recycled materials for the building construction, and then they have achieved a Griha 5-star certification. And how they have done it is that uh, uh, only 8% of the annual energy that is generated on the site is through photovoltaic and windmills, and then 92% of the energy that is consumed by the project is sustainable energy, which according to them makes it a zero energy project. You can see further design elements or techniques which they have used uh, in the building design. You just go to this link and see. So for example, you can see that they've used aluminum louvers as a protective skin, which allows daylight and ventilation when it's required. So you can read about the further details about the design of this building if you want to do that. But the question's answer, I think it's clear. It is a building which is located in Pune, India. So I think the answer to this question also is clear to you. That is all for today's session. Thank you very much for attending. Now I'll take any questions if there are further questions. Okay, NS Easy Road map file is not opening on Google. Let me check once again. Okay, this is actually another link to another website which I've given you for the study for net zero energy building. So this pertains to specifically to net zero energy buildings in case of India. So like you can see, I think it is opening. There might be some issue earlier. You can, Tara, I think it was. You can try opening the link again. You will go to this website, or if not, you can just try and finding net zero energy buildings nzeb.in, and you can go see what this website provides is are the details about net zero energy buildings and net zero energy building regulations in India, so for different states. So for example, for Assam, you can see it shows that various common measures have been taken in Assam. So an ECBC cell has been set up in the state. Then, for example, in Andhra Pradesh, process of implementing the Andhra Pradesh ECBCs is ongoing, and bylaws have also been amended to incorporate ECBC. Then for Arunachal Pradesh also, an ECBC cell has been set up. For Bihar, and UCBC cell has been set up. Uh, then for Delhi, as of 2018, ECBC has been drafted and circulated for suggestion and comments from various stakeholders. So, like this, updates on the net zero energy buildings you can find. You can even go to this link and find several case studies from South Asia, or even from all over the world. Why I'm showing you South Asia is because South Asia have the climatic conditions which are very similar to India. So you can find some studies or some best practices which can which can guide you to how the net zero energy buildings are being constructed, or what techniques are being used, and how those can be uh, incorporated in the Indian cases as well. So, for example, you can see this. Okay, so these are the different case studies, and you can even go and see more information about each of the case study. So, for example, this is the Arthur and Century Pacific Tower. So you can see the performance details, what performance details are of the building, and then additional details about the building. Uh, then let's see this. It's taking quite a while to open, but you get the idea that you can go and see example of different buildings and how they have uh, achieved, or how the buildings are trying to achieve net zero energy status, what techniques they are using, what materials they are using, and things like that. So see, like this is the example of Shenzhen Institute for Building Research headquarters. So you can see the details of the building, and then what cost and energy savings the building has done using the different materials and techniques. Then you can even see the key sustainable feature, like for water conservation they have rainwater collection, water saving appliances, uh, recycled water usage and things. Then what materials they have used, then what are their solutions for daylighting, for artificial lighting, then individual controls, for example, light switches and and operable windows near workstations. Then what carbon reduction strategies they are using. Then uh, other sustainable features like water loop heat pump and water source heat pump for their HVAC and things like that. So you can go into the details of each case study by visiting the links, and then you can see what techniques different cases have employed. Okay. I hope this is clear. So there might have been some problem with the website or the internet. You can just visit this link again and open this website. If not, just go to nzeb.in and try to find this website. I hope that is clear. I think the sources you is very good at. Okay, thank you so much for that, Tara. Uh, Any more questions about the session? Tara is asking, can you share this PPT as you joined late? Okay, Tara. So whatever material which I discuss during these sessions, these will be shared with you. There might already be a shared folder which you can access. I think you might have gotten an email about it. So there is a common folder, common drive folder, which I have provided a link for. So the link would have been provided to you through email, or even when you visit your SWAYAM page, there is a link for these live sessions and the common folder where all the study material is shared. So you can just go to that folder and you can access the link to the all the presentations. So all the presentations which I discuss, all the associated material and links to everything will be in that folder itself. I hope this is clear. Okay. So all of the PPTs and the links associated with this is there and you can access it there. I hope that is okay. Any questions apart from that? So you can ask questions from this week's material. Any questions if you have from today's session, any doubts or any such things. Anyone apart from Tara? If you have any questions, please go ahead and ask. Okay, Sagar has no questions. Okay, Tara is asking that in India it is not possible for sustainable building as we have no money or same or any industrial inputs. Okay, so this is true that many a times the sustainable building techniques or the sustainable design techniques which we use, they are not so efficient in terms of the costs they incur. But if you follow the bioclimatic architecture techniques, which borrow a lot from vernacular architecture, you can see there are a lot of examples of buildings in India which are sustainable in nature. Especially if you see buildings which follow vernacular architecture, even they are considered sustainable building. I agree that bioclimatic architecture, especially which involves a lot of technological inputs in the building design, it becomes many times it becomes very cost intensive. Uh, but in many cases, uh, the cost which it incurs at the beginning of the building's life cycle, it makes up for that cost in the long run. How it makes up is that in the long run, when the energy usage of the building or the energy that is used by the occupants within the building, that usage is reduced. So the cost that the building is incurring in the long run in all of this energy usage, uh, that is actually higher in terms if it follows the traditional building construction techniques. In comparison, if you put some additional costs in the initial stages of building and then employ techniques which are more energy efficient. So there are some examples also which do this comparative study. So which study that if initially you use more energy efficient techniques, so over a period of time, uh, the money that is spent in using those sustainable techniques is recovered by how much the cost it saves in the energy usage of the building. So I don't have the links to those studies now, but I'll make sure that in the next session I'll bring some of those studies to you. I'll share the links to those studies if you want to study them in detail. I hope this is clear. And then also there is currently there is limited participation uh, from the both the government side and the industry side, but that is slowly changing as use of renewable energy and sustainable design techniques is being incentivized more by several international agencies and the government itself. So that is happening slowly, and but definitely even India is moving forward towards more sustainable building techniques. I hope this is clear. Any other questions? Okay, Arvind is asking, could you elaborate or provide more info on sustainable mountain architecture, which will help in your thesis because it is situated in Ladakh? Okay, so Arvind, we showed an example of the, I'll go back. We showed this example of school in the sky. So if you want, you can go further into details of this particular case study. You can go into more detail how this building is constructed, what materials they have used, what techniques they have used, so that you can gain a little insight into sustainable techniques used in hilly terrain or mountain, as this particular case study is from Nepal. Uh, in today's session, I don't have any more examples which I can share, but I'll make sure that in next session I bring some more examples of buildings which used more sustainable techniques. Okay. Tara is asking, can we get material details of building building to make sustainable? So, Tara, you have to visit the links which I shared. In many of the studies which I have mentioned, there are links to different building materials, how they can be used. So, for example, let me go back. Okay, so this particular study, if you see, this particular study talks in detail about energy and environmental assessment of high performance building envelope in cold climate. So it talks about uh, their conventional stud wall design and how the materials which are used in the construction of stud walls, uh, how uh, they create a high performance building envelope for a cold climate, and then different aspects of the sustainability of the materials which have been used. So the details of the double wall studs have been provided here, and then the materials and the conductivity of different materials, how it plays into the building performance, and then several aspects of sustainability of the material you'll find in this study. So, for example, you see what effect the different materials have in terms of human health, in terms of ecosystem health, and in terms of the resources they consume. Uh, so this has been studied in terms of what environmental damage each of the material which is associated to that specific building design technique is mentioned here. So, for example, this is one study you can go and see in detail if you want to learn more about specific building techniques. I can't comprehensively cover all the different building materials or all the different building techniques, but if you want, uh, but if you want uh, to see or you want to learn more, you can go to, I have provided many links in the PPT, and you can go and see the details of building materials and techniques there. You can even go to the case studies which I mentioned from that website, and from those case studies also you can find several different examples of different building construction techniques, or different or details of the building material and things which are used by different buildings in example in uh, for example of different types of climate. So if you want for cold climates, there might be some, if you want for hot, warm, humid climate, you can go see examples of buildings in south and southeast Asia. So I hope you can get examples from there. Okay, if you have any uh, further doubts, please ask. Anyone else apart from Tara and Arvind, if you have any doubts, please go ahead. Sustainable rating toolkit, do you have any? So you can, for there are several tools like the Griha Lead ECBC toolkits you can follow. I think in the further lectures those tools will be discussed more. We have not reached to that point yet, so that we can discuss the specific tools in detail, but that is coming up in the upcoming lectures, and we'll go into detail of specific tools also. Just hang in there for the upcoming lectures. Any more questions? If anyone has any more questions, please go ahead and ask. I think there are no more questions as no one is asking. So I'll close the session for today. Thank you very much for attending this session. I hope you are getting your doubts cleared. If you still have further doubts, you are very welcome to post your doubts or your queries on the NPTEL discussion forum. Either me or Professor Shivaji can attend to your doubts there, and I'm sure your doubts will be answered. Or even in further sessions, you can ask any doubts pertaining to the material which has been covered up until now. Okay, thank you very much for attending today's session, and I'll see you in the next one.